So a version of this could be sine squared x replaced with 1 minus cosine squared x. You could equivalently move sine to the other side. So if you start with sine squared plus cosine squared is equal to 1, we can move the sine to the other side. And we can end up with cosine squared x is 1 minus sine squared x, right? Sometimes we could even substitute 1 and put this left-hand side in its place. So there's a lot of variety that could come from this. But as I said, that's not the only way I use this particular formula. I also use this formula to find the other two. So how can we use this formula, the sine squared x plus cosine squared x equal to 1, to arrive at the other two Pythagorean identities? Because again, this is the only one I memorized. The other two I just solved for. We can do one of two things. One option we have is to divide everyone by sine squared x. This first one is sine squared over itself, so that cancels, and this just gives us a 1. Plus, and then what's technically happening here is you have cosine x over sine x, and the whole quantity is being squared. Now, we don't typically write this middle step, but it's a good idea to kind of see that that's happening. But cosine over sine, let me copy my 1, cosine over sine is cotangent, so this is cotangent squared x, equal to, again, technically 1 over sine x quantity squared, but that's a reciprocal identity, and so this gives us cosecant squared x, and that's a second Pythagorean identity. How do we get to the other version of this? Well, we start the same. We start with sine squared x plus cosine squared x is equal to 1, and this time we're going to divide everybody by cosine squared. Okay? So what that means is sine over cosine, again, technically it's quantity squared, right? But sine over cosine is tangent. Cosine over itself, again, that cancels, and we're left with just plus 1, equal to, again, technically 1 over cosine x quantity squared, and that's a reciprocal identity as well, so we end up with secant squared x, and this is your other version. So your three Pythagorean identities are sine squared plus cosine squared is 1. Another one is 1 plus cotangent squared is cosecant squared. Notice the cos go together. And the third one is tangent squared plus 1 is secant squared. Now, with the middle two, actually with the first one as well, remember we have what we call the commutative property of addition. And just kind of a quick idea of what that means. That means that I can add two things in any order and they're still the same, right? If I say 1 plus 5, that's the same as 5 plus 1. The solution doesn't change. So with all three of these identities, the order that they're written in, as far as the addition half, does not technically matter. So for example, for that second one, you could say cotangent squared first and 1 second, and get cosecant squared on the other side, and it means the same thing. Equivalently, we did this with the first set of identities. You can rearrange them as long as everything is equal. So I could subtract the 1 from both sides, and I could use cotangent squared. Maybe that's written in, and I swap it out for cosecant squared, and we swap it out for cosecant squared x minus 1, or vice versa, right? Maybe this is in your identity and you swap this in its place. There's different variations to this. If I were you, I would suspect a Pythagorean identity whenever something is squared. Now, it's not always going to require a Pythagorean identity, but, 3.5, 4 times out of 5, it's probably the right direction. So when you see squared functions, especially multiple squared functions, sines and cosines, things like that, think about Pythagorean identities, okay?